Good day everyone. The God in me greets the God in you. God bless you. In this video presentation, we, Group Volt³, will present our approved project for robotics, from its description to the virtual prototype in Tinkercad. To begin, let us have Kanna Arellano for the description of our project.
Automatic roof covering system is designed to protect crop fields from excessive heat by using temperature and ambient light sensors to monitor environmental conditions both inside and outside the field. When the temperature reaches critical levels, the system alerts users through an LCD display, LED indicators, and a buzzer, providing visual and auditory feedback. A push button allows manual control to activate or deactivate the system, giving flexibility during setup or maintenance based on the detected heat level. The system responds accordingly: green LED for safe conditions, yellow with slow buzzer beeps for high temperature, and red with rapid buzzer beeps for extreme heat. In the case of very high temperature, two servo motors automatic close the left and right sides of the roof to shield the crops and maintain a safer environment.
Arduino Uno, one piece. This serves as the brain of our project. Is process all the input signals and sends command to another component. Servo motor, 2 pieces. These motors are used to open and close the roof automatically depending on the temperature or light level. Photoresistor, 2 pieces. These detect the amount of light in the surroundings, helping the system determine if it's sunny or dark. Temperature sensor, 2 pieces. They measure both the internal and external temperature, which allows the roof to adjust based on the heat levels. Green, yellow, and red LEDs. This LED serves as indicators for different temperature or safety levels: green for normal, yellow for warning, and red for danger. Buzzer. The buzzer alerts users when the temperature exceeds a certain limit. LCD 12C display. This shows the current temperature and system status so users can easily monitor the surroundings. Push button. This acts as a manual override, allowing user to control the roof when needed. Resistor. This limit the electrical current in the circuit to protect the components.
Moving forward, this is the process flowchart of our project, showing how the system will function. First, the system displays on the LCD a roof system ready text. Then, it detects if the push button was pressed and turns itself on or off depending if the system was already active. If the button was pressed while the system was on, the system will turn off. If the push button was clicked while the system was off, the system will initialize. However, if the push button was not clicked but the system is already active, then the system will continue its operation. Second, two pairs of ambient and light sensors will activate once the system is on. The first pair has one ambient sensor and one light sensor within the cover field, while the second pair is found outside the cover field. Both pairs will initialize and display its current levels on the LCD display. Third, the system will identify the action needed depending on the external temperature. If the temperature sensor outside the cover field detects temperatures below 29 degrees Celsius, the alert will not activate. The green LED will be on, the servo motors will keep the roof open, and the buzzer will not play. The text on the LCD will display all 4 sensor readings. However, the system will initialize a caution alert when the external temperature is between 29 degrees Celsius and 30 degrees Celsius. The system will warn the user by displaying a caution text with external temperature underneath the text. Additionally, the buzzer will play with a slow, continuous beeping, and the yellow LED will turn on. Moreover, the servo motors will still keep the roof open unless a higher temperature is detected. Once the external temperature reaches above 30 degrees Celsius, the system will begin the danger alert. The LCD will display a danger text with the outside temperature below. Then, the red LED will turn on, the buzzer will beep at a much faster and continuous rate, and the servo motors will activate, closing the left and right sides of the roof. There are many benefits of using this project, and to have a further discussion, let us have Arjon and Andrin for the significance.
According to the Intergovernmental Panel on Climate Change 2022, global warming remains a serious issue that continues to affect agriculture and plantations worldwide. According to the Mondal ETAL 2023, rising temperature due to climate change cause heat shocks in crops, which limit growth and reduce productivity. Similarly, Dhaliwal and Williams 2022 state that temperature exceeding 30 degrees result in yield decline for sweet corn crops. According to Srensta ETAL 2022, when the temperature rise above the normal range from rice crops, it can lead to withering, curling, and yellowing of leaves, as well as slow seeding and root growth. Due to these findings, a solution to reduce temperature during high heat exposure is essential according to MAU ETAL 2024. Shading system can lower greenhouse temperature from 29.5 degrees to around 27.3 degrees, preventing heat stress in plants.
Our roof system project can benefit those who own lands or field crops, such as farmers and businesses. They will be able to protect their plants against the high heat, helping the crops to grow safely through this automatic roof covering system. Now that we have discussed the project, let us show you the virtual prototype created in Tinkercad. This is the circuit diagram of our project. As you can see, there are two breadboards. The larger breadboard at the center contains the inner temperature and ambient light sensors, as well as the alert systems and the display. This breadboard will also be connected to the two servo motors for power and ground. The second smaller breadboard is for the external temperature and ambient light levels. Now let me show you the code and explain the structure. This code was initially made by ChatGPT and was refined and organized by Blackbox AI. We begin by including the libraries for the LCD I2C display and the servo motors, and assigning the pin connection for our components. Then, we insert the constants and thresholds such as the caution and temperature levels, angles for the left and right servo motors, and the speed of the buzzer beeping. After that, we will initialize the LCD and the servo motors. We will also insert variables to indicate when the system is active, the button is pressed, or when the buzzer will play. We will also add the speed for the LCD to update its text. Variables that will be displayed on the LCD are also found here. The setup function includes initializing the LCD, adding a custom degree symbol for the display, setting the pin modes, attaching the servo motors to their pins, and opening the roof by default, and displaying a system-ready text on the LCD. Afterwards, we will create functions that will be used in the main loop function. The first function is the handle button toggle. This function detects if the push button was pressed. If the button was pressed while the system was off, the LCD will display system on for a short period of time and begin reading the sensor data. Otherwise, the system will display system off for a short time. When the device is activated, the system will also identify if the external temperature that was read previously is either danger, caution, or normal, and the assigned actions will initialize in the void loop function. Additional code to display the LCD screen immediately and consistently are also used. This line will also update if the button is pressed. The second function is used to convert the temperature to Celsius and the ambient light to percentage. The third function is used to update the LCD display with the values from the sensor readings. To prevent the LCD display from continuously flickering from repetitively updating the text, the LCD will only update the text if any of the previous values have changed. In normal operations, the system will display the internal temperature and ambient light levels on the top and bottom left, respectively, and the external temperature and ambient light levels on the top and bottom right, respectively. However, if the system is on caution or danger operation, the system will instead display the caution or danger text with the external temperature below it. In the fourth and last function, the alert system functions are set. These include rotating the servo motors, turning on and off the LEDs, stopping and playing the buzzer. The buzzer also contains a short code on the duration for each beep of the buzzer. Finally, the main loop uses all of the set functions and variables to control the system. It begins by checking if the button was pressed and turns itself off if the system is turned off. If it is active, it will read the temperatures and ambient light of both internal and external areas and determine if the level is normal, caution, or danger. In normal cases, the roof is open, the green LED is turned on, and the buzzer is off. In caution cases, the yellow LED is on and the buzzer plays with a slow beeping speed. In danger cases, the roof will be automatically closed, the red LED will be turned on, and the buzzer will play at a fast speed. Lastly, the LCD display will update at a regular interval if the levels change. The third mentioned function for the LCD display will show the appropriate details based upon the level detected. Now, let us have a demonstration of our virtual prototype by starting the simulation. As a short disclaimer, the simulation may produce delays or lag when testing. So please refer to the simulation time above. The servo motors shown in this simulation are facing sideways, meaning to say the servo motors are laid down flat sideways, so that the roof opens and closes at the shown direction. The roof will be attached to each end of the servo motor to rotate. When the system turns on, the left servo motor needs to rotate because the servos are only limited to a 180-degree rotation, and both servo motors cannot rotate clockwise from their initial given position in the simulation. Through this project, we will be able to create a safe environment for field crops. Again, I am Enrico B. Manguerra, the leader of Group Volt³. Thank you for watching.